Welcome back to my channel Medicine Hub 101. Today we'll talk about bipolar limb leads in terms of the ECG. Okay, so I'll just discuss the whole topic in terms of the three levels just today for today, at the level of circuit, at the level of axis, and at the level of pattern. Okay, before starting the topic, let's talk about what do we mean by lead. Okay, what is lead? So lead is nothing but on top of the electrode that is connected with the wire, and one part of the wire that will be connected with the ECG machine in terms of the galvanometer over here, and another part that will be getting connected to wire within the body surface. Okay, so you can write it over here just like this, that the lead is nothing but it's on type of the electrode that is connected with the wire, and one part of the wire that will be connected to wire within the body surface, another part of the wire that will be connected within the galvanometer, the ECG machine. Okay, now see, if you write it over here, that lead, what is lead over here? Okay, so we can write in this way, as the electrode that is connected with the wire. I'll show you in the diagram. Okay, now see, for example, I'll show you. For example, I'm just considering this individual for hypothetical. I'm just taking this part over here. See, that is individual. Okay, we'll see what is laid over here first. There is a machine, ECG machine over here, the galvanometer first. Is the galvanometer, and we'll see over here it is having the electrodes, two electrodes just like this, and I'm showing it. Okay, and we know that there is ECG paper. Okay, let me show you here. And whenever the machines will work, the ECG paper that will move in these directions. Okay, the ECG paper that in these directions. And for example, I'm just assuming, okay, this is the positive side, this is the negative of the electrodes. Now I'm just taking the electrodes is connected with here on wire and another wire over here. Okay, now you are getting what? The leads. That means the leads is nothing but the water connected with the wire. One part wire within the machine, another part with the body surface. Okay, now let's talk about what is the functions or the purpose of the lead. What is the functions and the purpose of the lead? Now see, whenever we are seeing the different kinds of the electrical activities that is going on the heart. For example, whenever we are seeing the atrial depolarizations, the ventricular depolarizations, or the ventricular repolarizations, so whatever the electrical activities that those are taking place within the heart, the thing that will be represented in terms of the what ECG by using the galvanometer. Okay, so in terms of the we can also leads over here. Okay, now see, let me write it over here, that whatever the electrical activity of the heart that will be manifested, that will be measured by the what? By the galvanometer in terms of the leads over here. Okay, and that will be represented in terms of ECG. Just like this. Okay, now see, if I just want to say you in details for a little bit, just try to understand from here, that we know that what the different kinds of the electrical activity, those are taking place within the what? Let me show over here a little bit more clearly for you. Okay, just like this. Now see, for example, I'm just taking this part. Now see, I'm just considering this the left ventricle, and I'm just considering this the right ventricle over here. Okay, and we know that if we just talk in terms of here in terms of the major ventricular depolarization, let me repeat this thing once again, that major ventricular depolarizations, at that time we'll see that we'll get the different electrical vectors. So whenever the ventricle that will go under what depolarizations we'll see within the ventricles, will get the productions of the millions of the electrical vectors. Okay, for example, I'm just taking the left, the vectors, electrical vectors will get in terms of the left ventricles. This is electrical vector. Okay, I'm getting in terms of, for example, the right ventricle. This is the right ventricle. I'm getting this one. Definitely the force, electromotive force, or we can say magnitude in terms of the vectors, electrical vectors, that will be less within the right ventricle, because the left ventricle, that is the thicker than the right ventricle. Okay, so definitely there will be more cells. If the cells are more over here, definitely the depolarization that will be more. As a result, we will see the vector that will be produced in terms of the left ventricle, that will be much more stronger. Now, if you just want to get the resultant, if you want to get the resultant vectors over here, we'll get what always we will see that this vector will be in terms of left and downward. Okay, we'll get the vectors. We'll get the vectors over here. That is known as mean QRS. Okay, let me write it over here. That is known as mean QRS vector. That means is the resultant of the left ventricle. The vector is electrical vector that is found in terms of the left ventricle and in terms of the right ventricle. Whenever we are just doing the additions, we are getting the resultant over here. That is known as mean QRS vector over here. Okay, that's the thing. Now this type of the vector we can just measure in terms of what by using the different kinds of the leads. Okay, I have already given you the idea what is the lead over here. Now we'll say in terms of any individual. Now see, let me show this another thing over here. I'll just consider an individual. I'll just consider an individual with whom we get this type of the thing over here. Okay, now see, I'm just taking the individual over here. Okay, this is the individual smiling, the hand over here, the trunk over here. Okay, now see, and for example, this is the lower limbs over here. For example, okay. Now see, I'm just considering the heart where we in the mid, where the heart is supposed to be. For example, I'm just taking the heart in these positions. Okay. Okay, now see. What can we do over here? That we know that the major ventricular depolarizations, the vector that will go in these directions, left and downward. Okay. That will go left and downward. Is the vector over here. Now to measure the vectors, we can use the different kinds of the leads. For example, I can use the lead over here. Now try to understand from these portions that whenever we'll see the the electrical activity will be seen over here. Okay, electrical impulse will get over here. As a result, we'll see from the heart the electrical activity will be spreaded in all over the body parts. That means from here the electrical activities that will be spreaded all over the body parts in terms of the upper limbs, in terms of the lower limbs, in terms of the trunk. Okay, everywhere you can see this type of the thing. Why? Because if you consider our body contains fluid, and we know within the fluid there are various kinds of the electrolytes, and the electrolytes they can conduct electricity. So as a result, we will see the electricity that will be also conducted from here, okay, to the different body parts. Okay. Now I'm just considering this the left side is the right side over here. Okay. Now see, I can use the different kinds of electrodes over here. Now first I will use over here on top of the lead. For example, let me show. Just like this, and we will see from here there are two electrodes that will be connected to the two regions, and I'm just taking the two electrodes that is getting connected over here. For example, if I just take the electrodes over here for the negative, whatever electric potentials will get over here, the same amount of the electric potential will also get in terms of the rest. So for conventional purpose, I'm just taking this one in this way, and the positive one from here in the wrist. So the positive one I'm taking in terms of the left wrist, and I'm taking the negative one in terms of the right wrist. Okay. Now see, by just doing like this, whatever thing we're getting, see from here to here, what? The ICG machine that is getting connected with the what? Body surface. Here also body surface by wire. Now this thing from here to here and here to here, all these things that is known as the circuit. So we are getting the what? Circuit. We'll get this is the circuit. What is circuit? Whenever the wires they are connected between the wire, in between the galvanometer, so you can see in terms of ECG machine and the body surface over here. So we are getting what over here? We are getting the circuit. Okay. Now from here, try to understand this thing that okay, let me show over here. Now we know that the electrical vector, that means from the major ventricular depolarization, they are in these directions. Okay, it will go left and downward. Now if I just consider a line, if I consider a line from here, for example from the minus to the positive electrode over here, I am getting a line. Now the connections of the line, the imaginary line that is connecting in between the negative and the positive pole over here, that is known as what? That is known as lead axis. This is known as what? Lead axis. So, okay, lead axis. This is known as lead axis. Okay. Now see, whenever you want to, if you want to measure the electrical activity of the, major ventricular, major ventricular depolarization over here, if I use only this lead, that means it is known as also the lead number 1. See, it is known as also lead number 1. It is known also lead number 1. If I use only the lead number 1, then I can get only the superior view. That means, for example, it is the what? It is going downward, left and downward. Okay. Now if we use any kind of the lead that is going from the left to right, just like this, in this way we will get only the superior view of the what? Superior view of the electrical vectors. Now just to represent all in terms of the, in total kind of circumstances, if you want to represent the whole thing over here, I have to get the view from the different directions. I have to get the view from the different directions. That means if it goes the downward and the leftward, now I have to get from here, I have to get from this side, I have to get also from this side. Okay, that's why I have to use more leads over here. Now see, for that thing I'll just take more leads. For example, here I'm taking one more lead and I'm just taking one more lead over here, just this one. Okay, and the negative pole and this is the positive pole over here, and definitely I have to use the galvanometer here also. For this let me use this one. Okay, this is the galvanometer over here, and this is the point over here, this is the point. Now I'm just attaching this point with the negative one, and I'm attaching this one with this one. Okay, now this is the circuit. This is the what? Circuit. This is the circuit over here. Okay, in the same way, if I want to get the view from these directions, then I can use one more lead over here. The left side, I'm using one more negative over here, one more positive over here, and in the same way I'll use another machine galvanometer over here just to measure these things. Okay, now this I'm just attaching the negative one, I'm attaching this one with the positive one. Now see, we are getting these are the wires, and then in the same way, if I just draw the imaginary line in between them from here to negative to the positive over here, negative to the positive over here in these cases, in the same way, if I just draw the imaginary line from here to here, okay, I get also the what? Lead axis. This is the first lead axis, the second one is the third one. So is the lead axis also I'm just taking in terms of the lead number 2, and this is the lead number 3. The lead number 3 over here. Now try to understand from this figure that whenever, for example, this major ventricular depolarization vector that is going in these directions, let me use the red color for it, then it will be more easier to understand for the colorfulness. Okay, see, let me show in this way. The major ventricular depolarization vector that is going. Okay, now see, whenever it is going downward and the leftward in this way, just try to understand from here that we are adding this what? This is the positive side. So this is the positive one, and is the negative one over here. Okay, in the same way is the what? Positive is the positive, is the negative one. Now try to understand from, we have to know some names. The positive electrode, that is also known as, okay, exploring electrode. Exploring electrode. And the negative electrode, that is known as a reference electrode. Reference electrode. Okay. Now see, for example, is the vector. is the vector, electrical vectors. Okay. Now whenever it will go is a positive, definitely you have to consider in terms of the positive over here. Whenever it will go towards the positive electrode, so whenever the electrical positive electrical vector that will go towards the positive electrode, at that time we will see the deflections within the, for example, is the, let me show once more over here. Okay, the deflections that will be positive, that means it will come upward just like this one. So the positive deflections we will see, as a result we will see whatever the thing within the ECG just like this. Okay, in the same way if we just see that the vector, electrical vector that is going, electrical vector that is going away from the positive electrode, that means it is coming for example towards the negative one. At that time we will see the negative deflections. We will see what? Negative deflection. Negative deflection, that means we will get just like this. Okay. Now in the same way as we know this is going what this vector, this electrical vectors, the major ventricular depolarization, this is going in these directions. Now how much portions it is attaching in terms of the parallel way. For example, if I just say from here to these portions, almost all of the parts of the vectors component parts that is totally parallel with the lead number 2. So whenever we are getting that this portion, the major ventricular depolarizations, this is totally parallel with the lead number 2. As a result, whatever the changes we will see in the lead, in terms of the lead number 2, in terms of the lead number 2 we will see the positive deflection that will be greater. Okay. Now see in terms of the lead number 1, if I just consider this is the lead number 1, now how much portion it is getting? If I just draw the perpendicular from here, if I just draw the perpendicular from here, perpendicular, I am seeing almost all parts that is getting parallel where in terms of the lead number 2 and the major ventricular depolarization. And in terms of the lead number 1, if I just consider the lead number 1 from here, try to understand that if I just draw the perpendicular line from here, we will get a little bit portion that is getting parallel. So in this case, we will also get the positive deflections, but the positive deflections will be not that much. In the same way, if I just consider for the lead number 3, let's see how much portions we are getting over here. We will not get that much part, we will get little less with respect to the lead number 2. In the same way, we will also get the positive deflections but less, not that much. Okay, so like this we will get this what? The positive deflections. Now see, whenever the major ventricular depolarizations is going left and downward from the 3-dimensional figure, if you just consider, we are getting from the superior view, this one, we are getting from the left side, the right side using the lead number 2, and with respect to the left side we are using the lead number 3. As a result, we are getting this type of the views. Okay. Now, see, for example, if I just see, if we see over here, try to understand from here. Let me show. Okay. For example, is the lead number 1. Is the lead number 1. That means, okay, number 1. Okay. Now, if we see that that means the electrical vector. So over here, the electrical vector that is going perpendicular, whenever we are seeing that what? The electrical vector that is going perpendicular in terms of the lead axis. As a result, we will see whatever the deflections we will see over here, we will see the positive deflections as well as the negative deflection. That means, let me repeat once again, whenever any kind of the electrical vector that will go with respect to the lead axis in terms of the perpendicular way, so whenever the electrical vector that will be seen, that will go in terms of the electrical axis perpendicularly. So as a result, we will see, for example, if I just divide this part, so it is coming towards the lead axis. It is coming towards the lead axis. After that, it is going from the lead axis. So as a result, we will see whatever the deflections we will get in the initial stage of the electrical vector over here, we will get the positive deflections. Okay, but after that, whenever the vector that will just cross the lead axis, after that it will go away from the lead axis. So as a result, we will see the negative deflections. It's like this one. Okay. So in the same way, we can also see any kind of the perpendicular. If I just consider the perpendicular for this one, if I just want to show you in this way, then you will get the same result. Okay. Now, yes, this one thing. Now see, for example, let me show over here. Whenever it is the what, basically what we are doing over here, for example, is the negative one, is the positive one. Whenever we are just adding using the lead, this sides. So basically you are just measuring the potential difference. So what's the main thing over here? When you are using the leads in terms of the positive electrode, in terms of the negative electrodes, basically you are measuring the potential difference in between these 2 points. Okay. So whenever we just change the positions of the leads, whenever we'll just do the replacement of the lead, at the time we'll see what there will be what changes in the axis of the leads. For example, if I just negative over here, positive over here, the axis of the lead will be in these directions. If I take negative electrode over here, positive electrode over here, the axis of the lead will be in these directions. Okay, that's the thing. Now, see, let me erase some part over here. See, the leads basically whatever why you are seeing the bipolar limb leads, the thing is over here. See, whenever we are using the leads over here, it is having the negative, it is having the positive. For example, the negative and the positive electrodes. That's it is known as bipole. And we are applying on the limb. That means within the what? Within the wrist, within the ankle, left ankle is the left ankle over here. Okay, this is the left ankle. So we can consider this whole thing over here. That what? It will be the bipolar limb lead. Bipolar limb lead because of what? We are getting the two types of the pole. Electrode in terms of the electrodes, positive electrode, we are getting the negative electrode over here. Okay, and we are applying where? Within the limbs. That's the reason known as bipolar limb leads. Okay, that's the thing. And we have I think you have understood already that what is the circuit. This is the circuit. This is the what? This will be the axis of the lead. So let me say once more. This is the what? Circuit of the lead. This will be the axis of the lead. And what is the pattern of the lead? Whatever the things we are representing in terms of the ECG, that will be in terms of the pattern of the leads. So for example, we are getting these portions over here. So when you are representing in this way, it will be the pattern of the leads. In the same way, it will be the pattern of the lead. It will in the same way, it will be also the pattern of the lead. Okay. So see you in the next video where I'll talk about in terms of in details a little bit part of it, where I'll talk about Einthoven's triangle and whatever the equations we will get in the subsequent parts of the video. We'll talk about all these things. Okay. So if you think this video is helpful for you, please do like and subscribe my channel and press the bell icon to get the notifications first to watch my videos. Okay. So see you in the next video. Don't forget to subscribe.